In the previous lesson, we have said that the inverse of a parabola is not a function. How do we know if something is a function or not? That is if we use a vertical line test. Suppose we've got a function of this nature. Let's see if the function and the points, the turning point is given as 2 and 3. And you will know that to get the inverse, our parabola will look something like this. Either will face there or face there, but at the end will be sideways, from right to left, left to right, instead of being concave down or concave up, but will be concave to the right and to the left. So to get the inverse, we know that we will have switched the x and the y values, and here we will have 3 is to 2 instead of 2 is to 3, because it's the inverse. So how do we know it's a function or not? How do we know if the inverse is a function? So this is the inverse and this is the original function. This is the original function. So we want to know, is the inverse a function? We use a vertical line. Because it cuts the graph 2 times, it is not a function. But if it cut the graph once, it was going to be a function. So the question arises, an examiner is asking you, how can we make an inverse of a parabola a function? Do you agree that if we can make one arm disappear, let's say we make this arm to disappear, it's no longer existing, that arm. This means that the inverse will have one arm as well, and let's say the arm is like this. So that is the arm of this original function. The original function has one arm, and its inverse will also have one arm. Then let's use a vertical line on the inverse. You see, it now cuts once, therefore it's a function. So what restriction can we put to the domain of the original function to make its inverse a function? That is if we draw the graph with one arm. What is the relationship between these two and the values of x which are here? Are they more than 2 or are they less than 2? So we can say that we can make the inverse a function if we draw the graph with the values of x that are less or equal to 2. You understand? That is how we can make the inverse a function. The same is true if we draw the graph with the other arm on this side. Let me use a different color. Let's use the color red. Suppose this time we draw the graph with this arm instead, and the inverse will now be like this. We assume that this no longer exists. Then we use a vertical line. You see, it cuts once. It's also true if we can draw our graph with only one arm, with the values of x being more than or equal to 2. So here the trick is, always if this question comes, you answer it the same way. If they say to you, how can we restrict the domain and the range such that the inverse becomes a function, we're going to say that x is less or equal to the x value of the turning point, or x is greater or equal to the x value of the turning point. Let's have another example. This time I want to give you on a Cartesian plane, something that makes a bit of sense. So we're going to draw our system of axes. A vertical line will be our y-axis. I want you to be able to see clearly how we work out these things. So let this be our y-axis here, and now we're going to plug in our x-axis, which is the horizontal line. So let the line be like this. Okay, yeah. So let me use the color, which is black. So let's say here we have the x-axis, here we have the y-axis. And suppose, I love using this function as an example. So even if it doesn't make sense, it's just a rough sketch, a rough example. So here we have 2 and 0. We have the point 2 and 0. And here we have the point 3 and 0. and here we have the point, no, here it's 4 and 0, and here we have the point, let's say 3 and 2, just for the sake of it, 3 and negative 2. Below, the values of y are negative. Okay, so let's draw the graph for the inverse. The graph for the inverse will be, first of all, let's plug the line of y equal to x, but I'm going to plug that line in blue. Remember we said that the inverse is a reflection in the line of y is equal to x. So I'm plugging in a line now. So the line will be the line of y is equal to x. The line must always pass through the origin. Okay, because it's the line of y equal to x. We said that's the line where the values of x are equal to the values of y. So this is the line of y is equal to x here. The line of y is equal to x. Whenever you see the line of y equal to x, just know that we are talking about a reflection. So now let's draw the inverse. What will the point 0, 2 and 0 become? Will now become 0 and 2. And the point will be here on the y-axis. The point will be 0 is to 2. The point 4 is to 0 will now become 0 is to 4 instead. So we're going to say that 0 is to 4. So the point 3 is to negative 2 will now become negative 2 is to 3. And the point will be somewhere here. That will be negative 2 is to 3. And we're going to join our points. Make sure, guys, you use a ruler when you're drawing these things. Because if it doesn't make sense, sometimes your teacher can penalize you. So, let's use a vertical line test. Must I use the color green? Let's say I use a vertical line test. Look, it cuts my graph 2 times. It's not a function. It means it's not a function. You see? Because it cuts my graph 2 times, we say it's not a function. So how can we make it a function? That is if we draw the original graph with one arm. So how can we place a restriction on the original function such that its inverse will now become a function? We must say that x is less or equal to the x value. X is less or equal to the x value of the turning point. Then we say, or we must say that x is greater or equal to the x value of the turning point. I'm making space there. So understand. So what am I going to do? Let me erase here. We said that always when they say how can we restrict the original function, we're going to look at the original function, the one that is written in black. That is our original function. How can we restrict the original function, its domain? How can we restrict the x values? The domain focuses on the x values. How can we restrict the x values such that the inverse will not become the function? The inverse is the one drawn in blue. And because it doesn't pass the vertical line test, therefore it's not an inverse, it's not a function. So we have to say that x is less or equal to the x value of the turning point, that is 3. Or x is greater or equal to 3. Then you get 2 marks if that's 2. In most cases, it's 2 marks. So make sure you grasp this. How can we restrict the original function, the one that is written in black, such that its inverse, the one in blue, will be a function? If we draw the graph of the parabola, the one in black, with one arm, even its inverse will have one arm and will pass the vertical test. But if we draw it in with 2 arms, even the inverse will have 2 arms and then will fail the vertical line test, the one that we did in green. Look, it didn't pass the vertical test because it cut here at the same time it cut here. But suppose we have drawn our graph with one arm. Let's say we have blocked this side. We had blocked this side. So I'm trying to make my work clear. So let's say we had blocked this side. You find that here we were going to have one arm as well. Let's say we're going to have one arm. And let's erase one of the arms here. And now when we use the vertical test, we see it now cuts once. Then we say that it's now the inverse is now a function. So how can we restrict the original function? such that its inverse is a function. That is if we draw the graph with only one arm. I hope you understand. And feel free to ask in the comment section. I always emphasize this. Ask for further clarification. And we'll be doing question papers to be able to explain each and everything which we have learned. Thank you for watching.